Okay. Okay, thank you everyone for coming out tonight to DevOps Live Meetup. Just a few short introductions. We're having a DevOps Days event, again, another conference, a 2-day conference at the end of August. So go to the DevOpsDays.org website and just check out the details there. We already started, it's already started open for early bird tickets. So, make sure there's a limited amount of tickets there. So make sure you go out to that. All Day DevOps is also still looking for CFPs. That's going to happen, I believe, in November. And then the other piece of advice or announcement is this DevOpsSec Leadership Forum that is going to happen here. So if you have managers or directors or anybody that wants to attend that, just talk to Chip back here or Maury, who's going to be our speaker tonight. You want to say anything else about the leadership, Chip?
Well, this is the second year that we'll be having it,
okay.
And it was pretty well attended last year. The content that we'll deliver is, as the name would say, all about DevSecOps. It is not a product pitch, and I make that very clear. This isn't something where we're up there trying to do a demo of our platform or anything like that. It's strictly supporting the DevSecOps community. And if you have leadership within your organization that you think would be interesting, please, there's a stack of invitations on the table up in the front there. Feel free to grab one and one of my cards, and happy to answer any more questions if you have them.
Okay, sounds great. And without further ado, we're going to leave it here to our guest speaker, Maury, and he's going to talk to us about the top. I'll let him introduce. Thank you.
Yeah, I guess the technical term is the shifting landscape of attacks. But 12 of us here, so I want to make this as interactive as possible. The pizza's way over here. Get up and get more pizza, right? So don't worry about me. Just a little bit about me. I'm a solutions architect, so I'm the technical side to Chip. He tries to talk technical stuff, but I try to stop him. I'm based out of North Carolina. My degree is in theatrical sound design. I love ham radio, piloting. I'm a firearms trainer and actually had a really, really lucky career, right? So I started internet web-based applications back in '95, right? So the first presidential election website we did. And so been lucky enough to be part of this and see the transition from the beginning to and through the waterfall, the agile, the DevOps, whatever's next. Again, I do want to make this interactive because this will get boring if I just talk to you guys the entire time. But the reason that everybody is in this room is really to support DevOps. And when I think of DevOps, I'm thinking of how do we deliver great software faster and more securely, right? That's everything that we need to do. And when we look at not just your normal slides of, hey, if you don't move faster, you're going to die kind of thing, the stats are 52% of the Fortune 500 don't exist anymore, right? Since 2000. Whether that's Blockbuster going out of business, you guys get why we're doing DevOps. It's why you're in this room. So what's really facilitated this is the use of open source and third-party software. Right? 80 to 90% of the typical application is made up of open source components, whether you think so or not. And this is what I do every day. And I'll have a conversation with an executive. No, we don't use much open source. We'll get into a POC. It's 80 to 90% of the application. It just makes sense, right? You guys were having a conversation about microservices, right? It doesn't necessarily even have to be open source. Like those microservices are going to be components that you embed in your applications. They're going to have open source components in it. Your Jenkins builds, your Bitbucket builds, all of those services that you use to build have those open source components in it. And we'd like to take credit for that, right, a little bit. So at Sonatype, we have a name kind of problem. A lot of people don't know the name Sonatype. Most people know, if you're a developer, know Nexus or Maven Central, right? So more than 10 years ago, our founders were key contributors to the Maven project. Right? So even before then, we were all about how do we deliver software faster? How do we enable the use of open source components in the development lifecycle? And what that led to was us creating Maven Central. Right? It is the largest open source repository for Java components, 146 billion components. And then after that, our customers said, hey, we really like this thing up here that we can download all the components. Can we have a place where we can put our finished products and maybe even proxy the components, right? So that led to Nexus Repository. There's an open source version, which we have over, that number's a little outdated, over 150,000 deployments of the open source repository manager. And then out of this, you could see some of the mistakes we made around how do we control components? Do we whitelist, blacklist things? And what we found is you guys can't ever know as much as needed for understanding security vulnerabilities and licensing about all these open source components and the versioning, right? So about 3 or 4 years ago, we really broadened our platform so that we're not just looking at a repository view, but we're actually looking at the things that you make, the binaries that you end up making, break them open, find the open source components, and then do the research on the vulnerabilities in the licensing, right? So 50% of our engineering team is research against the vulnerability database that we have, right? So we don't just bring in the NVD, it's about 11% of our data. The rest of it's human curated. Because the whole point of this and the thing we've done for 10 plus years is automate this. You guys were having a conversation around automation, right? You have to automate security into this. And Java's not dead, no matter what anybody says. When you start to look at all the offshoots of Java and Groovy and Kotlin, and it's 146 billion downloads last year, right? So we know a little bit about scale too. I mean, this is a cost to us. It's a huge cost to us, but it's something that my CTO gave this talk somewhere a couple of weeks ago, and I was looking at the video, and he said, "Yeah, it's something we do to the community." No, we do it for the community. We don't burden them with Maven Central, but it is true. It's like we have a unique view into the Java components, and they're viewed, and we can actually provide some insight to our customers around that as well. Any questions so far? Again, I want to make this interactive. None of this should surprise anybody, right? I think the numbers will eventually, and kind of where things are going. Part of that visibility is not only in the components, but those 150,000 deployments, even though they're free, those customers actually respond to our surveys. And our latest survey around the use of open source components really led to some interesting numbers. There's a whole nother presentation on that, but I just yanked a couple out when I'm talking to individual companies, right? So if you think, so I heard AT&T, just call out whatever company you work for real quick. Okay.
KPMG,
KPMG.
Trade Station.
Yep. Anybody? Okay. Even at Sonatype, right? So these are your typical organizations. So this number here, 170,000 Java components downloaded annually, isn't just like an industry or insurance. It's that one company inside it, right? 3,500 of them are unique. So why are there 170,000? Well, when you actually run a report and see how much data, how many components have been downloaded, there's a repository and components that have 14, 15 different versions of the same library in the organization itself. 11% of those have known vulnerabilities. That's a huge number. Who loves JavaScript, by the way? And npm install. How many do npm install one package name? How many modules actually get? Yeah, it's a huge number. In the typical organization, it's 60,000 components per developer that are downloaded annually. 51% of those have known vulnerabilities. Right? 51% of them have known vulnerabilities. I skipped one here. One of the things that we have insight to is it's not just that a lot of these components are being downloaded into your environment. They're being downloaded directly from the developer's desktop and the build tools themselves. So this chart here is, again, with Maven Central, if a customer asks us to, we can give them a report on all the things that we've seen them download, right? So give me your external IP addresses. That's the only way we ever know who's who. But we provide them a report of what components have they downloaded, what percentages have CDEs associated with them, and one of them is where are the downloads coming from, right? So think the browser type, right? Essentially, 90% of them are coming from something other than a repository manager, right? The idea is you're putting these repository managers in place to help you cache and maintain security around these components. But the reality is this M2E here is your developer's Eclipse on the desktop, right? Add IntelliJ, add all of the Maven components to this. And these components not only are being downloaded by in this case, billions, right? They're coming from not a central place in your organization. They're coming from the desktops of your developers.
So, but do you think that's because the CI/CD pipelines have proxies and caches in place? So if the developers downloaded it once, or they download it over and over and over again, but when it's time for your CI/CD stuff, it's gonna download it locally because it's been cached in your network. So it's not gonna, the traffic for that isn't going to be reflected in the public repositories.
It isn't, right? So this is when you start to try to clean up these open source components. Let's say we find a bad component in our environment and we try to clean it up. To your point, it's cached at every developer's workstation. It's cached at every build's workspace. So without a proxy in the middle where the build tools are actually coming to Nexus to get it, the developers coming to Nexus to get it, there's still those locally cached copies that occur. Yeah. So think about these numbers and think about what he just said about the amount of places that I'm actually caching those, right? So those download stats are actual downloads. That means there are cache misses and we were going to get those components. So it's a huge number. And the whole notion that I can control this in a company, right? Oh, we can just figure out what the developers are downloading, what they're using. They'll tell us what. It can't happen in a manual way, right? So the numbers are staggering. The piece of this here is that if we treat the software development lifecycle like a supply chain, which most companies are doing now, would you guys feel like you guys are kind of treating it like a supply chain in terms of, do you know where the components are, right? Are you using the best components? Right, so there's some tried and true stuff around this. So when you look at something like the Chevy Cobalt here that had an ignition switch failure where 124 people died, the engineers fixed that problem before these people died, but they didn't have a version number on the release, so that actually didn't get out into the cars. Right? So this is the 737 MAX. Everybody's the last two plane crashes. Right? My brother-in-law is a pilot for Southwest. They know how to disable that very quickly. He even told my father after the first crash, it's like, yeah, that's something we train on. So if you fly Southwest like I do, you're fine. But the idea is this is a software issue, right? So are we managing the software like a supply chain? Do we know where that code is? Do we know the components that are being used? This E. coli outbreak is this week, right? Yesterday, day before yesterday, right? But now these industries know and can work through the supply chain and know, hey, we're gonna trace the source of the raw to grocery stores and restaurant locations. I'm glad they do it. It seems like but that's what you have to do to secure their supply chain. And software is no different, right? We have to adopt these industry standards around a supply chain, and it's amazing how well they fit together. So the talk is really about how are these open source components, the vulnerabilities that exist, and securing them. How are they changing over time, and what's next? And I apologize for how small these are, but if we look over time, we most understand kind of the early stage of security of applications, right? And it's really about the network attacks. And so if you've been in this business long enough, right, there's the whole network security certifications that you could go through and all the routers, and even still my routers having to do firmware updates. But it was really focused on the network and the flow inside. When we're looking at codes, if you look at OWASP, the top 10 things they're looking for, even in 2010, right, you have your normal injection, cross-site scripting, right, your typical application level type vulnerabilities. And then in 2013 and 2017, you get this other thing that's added to the OWASP top 10 list. And it's interesting that it stayed the same, number 9, between 2013 and 2017, using components with known vulnerabilities, right? So that's become this thing. It's like, okay, we know you're supposed to look for all of these things, and these are the top risks associated with it. But if you don't use components that don't have any of these, right? So when we say using components with known vulnerabilities, guess what the vulnerabilities expose for those known components? 1 through 8, right? So I'm not surprised that it didn't move to the top. These are the problem. Are we actually delivering code that is enabling these in our applications? And the answer is yes, every single day, right? And then what this has really led to is this disturbing attack on the ecosystems themselves. So no longer are we waiting for the component to have a bug, have it fixed, have it publicly released if there's a bug, and then have it exploited, right? We're attacking the ecosystem itself, the providers themselves. Again, we have visibility to that because we have billions of components that we serve up every day. Questions on this? How many people are familiar with OWASP and what they're doing? Okay. So a little bit of the history around these components with known vulnerabilities. Right? Everybody's probably familiar with Struts. Right? This goes back to 2013, but this is the big one with that. Really, all of the things came together, kind of the perfect storm, where you have all of these things are associated with the vulnerability itself that just lent the availability of these vulnerabilities to be abused often and easily, right? So it's network exploitable. It's not really complex. You don't have to have any authentication. So all of a sudden, you have these things that are exposed externally that people can just search for, right? If you know, it's not hard. You can use Google to search for the file extensions for the action types of Struts and actually find vulnerable Struts components today. Right? My bank has one person that's still trying to find all the Struts 2 components within their applications manually. It upsets me a great deal. So it still happens, right? It was such a problem that the FBI had to issue a flash alert, right, to companies saying, hey, we are seeing this traffic, and actually provide, if I show down here, provide the attack signatures so that companies could start looking for this. Kind of unprecedented at that point, right? Because it was so easy that you already had Chinese hacking tools being able to allow it. You just run it, install it, and you've got a shell. Metasploit, right? That exists today. I can do that. I have a Struts 2. All you have to do is download the Struts 2 showcase application, and the vulnerability is in that showcase application. So I've got it on my laptop. I can fire it up in a Docker container. I can run Metasploit against it and actually have root access to the server, because nobody ever runs their web servers as root, right? Ever. These Docker containers don't run as root. And this really led to, we had to name them this time, right? Heartbleed and Shellshock, right? So we're just progressing along. And then it starts really when the Struts component is very popular, but aside from common is in the name of this package, the commons collections bugs around JBoss and those systems were really devastating, right? You end up with not just people getting root access to servers, but this is the Hollywood Presbyterian Hospital. It turns out that they were ransomware for what, 17 grand in Bitcoin. They paid it, right? but they didn't have their computer systems for a week. They were doing paper entry for a week because this open source vulnerability allowed them to access the servers and shut them down. And in their announcement, they said, yeah, it would cost too much and would take too long. We paid the $17,000. Nowhere will you find that anyone died in this, but mathematically, like our CTO likes to point out, mathematically, it's kind of not possible that it didn't happen, right? When you look at the numbers around the mortality rate for people during the Boston or New York marathons, right, where you have to route an ambulance around those, the mortality rates significantly increase, right? If you're unlucky enough to have a heart attack during one of those two events, because it's just taking you longer to get to where you're going. These are the kinds of systems and the kinds of problems that exist. These are known vulnerabilities. I pointed that out, right? We know they exist. We knew that they exist. So really, this led to what people kind of blame Equifax, probably because they have all of our data, right? But they're my customer, so I'm kind of partial to them. They were my customer afterwards, right? So they did a pretty hefty evaluation, and they've really righted their ship. But they weren't alone back in the middle of 2016, 2017, where everything went right. You had the Apache Struts folks, right? Our CTO Brian Fox and our co-founders, they're on the Apache board, so they're seeing this traffic that's going through. But everything happened the way it was supposed to. So they found the vulnerability, they announced the vulnerability, but all through this time, right, you end up with these probing attacks that are occurring across. If you had patched when the patch was released, you would have been fine. But a huge number of companies didn't patch and still haven't patched to that, right? So as you come through, it's not until a month and a half later or 2 months later where Equifax realizes, okay, we've been breached. There's a whole series of other things that goes on, right? It's not just about this one vulnerability, although this is the one vulnerability that gives them access to all the bad things that were happening in the back, like shared network and database passwords and connectivity to systems that shouldn't have been connected to each other. But the idea is it's not just Equifax, and this comes through, and you have a couple of month period that occurs here, but everything happened the way it was supposed to. The Apache team fixed it, they announced it, and then the exploits happened right after the announcement. Yeah.
That 3-day span, is that the the exploit was active?
Yeah. Yeah. So if you from the time the announcement happened to the time the probes started happening was 3 days.
How long did it take them to detect?
Month and a half.
Oh.
Middle of that whole timeline. Yeah, had a lot going on. It's understanding, and this comes back to why having human curated data and having security built into the development systems having to come into play, because you can't keep track of all of the announcements that occur, right? And part of this talk is the announcements that occur about the vulnerabilities aren't going to help anymore because the attacks are happening earlier and earlier. Again, from that survey that we just did, right, I love this tagline. One of our marketing people put that in, and I got a sticker made out of it. But you have to automate faster than evil now. So what we've seen is 45 days. 24 minutes. Yeah. 4 to 5 days, and then 3. That's that 3, 4, 5 triangle if you into construction. But 45 days was the typical time between the announcement and the exploits being able to happen. It's 3 days now, right? So let's go back to slide 1 where I'm trying to release faster. I didn't go through that whole slide, but people are trying to release, I think somebody said quarterly, daily, hourly. If you can't release a patch within 3 days, you're going to be vulnerable, right? So it's not just about being fast enough to compete with my competition, but can I actually deploy these fixes as quickly as I can. Right, so this number is staggering. You have to be able to automate this process. And what's driving it is the economics of cybercrime, right? What's more lucrative, cybercrime or drugs? Cybercrime. $1.7 trillion in 2017. 500 billion in the drug trade in 2017. Right? It is the most profitable type of income of crime, and it's organized, right? So we're talking about, these aren't just little script kiddies in mom's basement, right? This is organized cybercrime, and what we'll see is that.
I bet that doesn't even count the bug bounty program. Because that's probably black hat crime.
Yeah, wait till you see a slide. Somebody gets paid for actually beating up the AngularJS folks. They actually got paid on the bug bounty too for injecting. I'm going to get ahead of myself, but and drugs aren't even a growth industry, right? Remember that hockey stick curve of the number of components that are being downloaded? I don't know about you guys. I love open source components. I don't want to stifle the innovation that's happening there. I need to have those components because I can't build the functionality themselves. So, I mean, it's getting worse and it's going to get worse year after year. So what we found is, it's not just this, I've got an open source component that has a vulnerability that's sitting on an external website and it's going to give my partial pieces of my data, like at Equifax. Now, this idea of being able to monetize the attack immediately, right? So if I can inject something that can monetize it, I don't actually have to, once I steal all this data from your database, I have to go sell it to actually make any money off of it, right? Right? Not with the cryptocurrency. And we'll have this conversation. People will say, well, we don't really want to secure, or we don't really need to secure the open source components because we don't have anything of value in our application, right? But the reality is the server has CPU cycles, your visitors, your build infrastructure has it, and the cryptocurrencies is the attack that's allowing that to be monetized. So the big one that occurred was Jenkins Miner. Right? So $3.4 million has been mined. So you get a miner into a server farm, right? If you control it, I mean, how many of you guys are running CPU monitors on your build servers, your build instances, right? I mean, the whole idea, some people are, but you've got to put the whole infrastructure around the APM side of that and measuring what's normal around those and checking for those. So you have these attacks that are now not just leveraging the mistakes that developers are making in the open source components, but they're actively trying to find ways to put these vulnerabilities into the components themselves. Right? So how did this happen? Right? A vulnerability, and it probably doesn't surprise anybody. It's a deserialization vulnerability, probably one of the most common ones. We all know. Not only do we know the vulnerabilities around these serialization problems, we know how to stop them as developers. Yet they still occur. Right? If you don't understand deserialization and serialization of components, take a quick read because it is fascinating. The idea that I can take this crypto miner, I can serialize it, feed it to your application, and then you blindly just unserialize it. And guess what? It's a transporter, right? It's a transporter from Star Trek. I'm taking this thing component over here and transferring it over here and then running it, right? But these are known vulnerability again. So it's not just the mistakes that occur. So this is really small, but the gist of this is there's a talk that folks give, a couple of guys gave on kind of they call it an abusive relationship with AngularJS. They love it, they hate it, but they were going to try to attack it in 4 different ways. And the 4th way was attacking the code base, right? So what they did, right, was be an open source developer. Right? They found this bug. They got really lucky. They found this bug that once patched, exposed a vulnerability that they can then exploit, right? So they come in, they're doing their good deed, say, oh, hey, you guys need to fix this. Put in a pull request. They don't mention the fact that it's going to cause a vulnerability, right? Then the next step is it gets pulled in, that gets exposed, they leverage the vulnerability. Again, they're not being super mean. They let everybody know. The Angular team doesn't know. The parent team knows. But the idea that just participating in open source, the way open source was intended, allows these kinds of manipulation of components, right? This is almost impossible to find unless you're really, 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 really good at what you're doing. I love the fact here, right? They even got the bug bounty for it at the end. So they fessed up, they explained everything they did. Technically, they fixed 2 bugs, but as you come through, and some of the more kind of, oh my gosh, did that really happen kind of events are mistakes or good guys kind of pointing out the bad things could happen. But there are instances where the bad things do happen. So a little bit of a tour here on some of the things that have happened over the past year and a half. And I joined Sonatype January of last year, right? I came from the APM world and then from the integration world at TaskTop, where I see the software development lifecycle and live in the software development lifecycle for years. And as I looked at what the next thing is, the thing that we had to worry about, it was how do I secure that SDLC, especially when I'm connecting all these individual components. And Brian Fox really saw this too, and he's been talking about this really before other folks. And as we start to look at it, we look at the progression of these problems, and we can start to see where this is going to go. But back in July 2017, there was a study that found the credentials online for 79,000 packages, right? They found access to the publishing credentials, right? So they're just mining the credentials at this point, not necessarily anything bad happening, but the credentials to publish were in open source repositories. How many people have? I'm going to admit something here. I was trying to work on something on my AWS instance, going through it. I couldn't figure out what was going on. I accidentally put my little token key into my configuration file and pushed to GitHub, right, on a public repository. I got an email from AWS within 30 minutes that says, hey, I'm sure you didn't need to start these 20 instances in every zone that we have. But that's how fast. Oh, and by the way, it was there for 30 seconds. I realized what I did, backed it out. But at that point, it was gone. I mean, imagine how often that's happened. I work for a freaking security company. And in a moment, you kind of make those mistakes. And it's not just, it's not just, hey, I'm going to mine for somebody's credentials, but you start to see on the NPM side things like typosquatting, right? So they found 40 packages that were out there for 2 weeks that were collecting credentials, right? Typosquatting is, hey, let me name a package that is really close to something that somebody wants. I don't know if you guys, some of these package names, it's not as easy as underscore, right? Underscore is easy. But you have this ability for folks that were trying to go fast, right? Somebody broke the build. Who broke the build? Right? We're trying to fix the broken build, and we'll see here in a second how that can actually lead to something worse. So it's not just the Java and the NPM world as well. It happened in the Python packages where there were 10 malicious Python packages. Again, basic info is collected. One's going to Russia, one's going to China, right? So I mean, again, these are coordinated kind of attacks against the systems. There's a blog. I'm harvesting credit card numbers and passwords from your life. Here's how. Google that, remember that, read that blog. It is scary as hell, right? He wrote it tongue in cheek, but for us in the business, we're like, yeah, that's how you do it, right? And it's really straightforward about how they're gonna, everything he has to do to actually get that through. And that was kind of a wake-up call for teams as well, because you're reading and going, yeah, I know exactly what it's doing. I know exactly how that's working. So it's a really good read. Thankfully, it's fiction. So we mentioned Java, NPM, Python, the Go repositories. Right? Here's an example of even big companies like Google are making mistakes early. We're moving so fast as an industry, right? So you have this Go bin data package, and in Go, the GitHub package or GitHub username is part of the identifier for packages, right? Nobody knows where this guy went. He was tired. He didn't want to do it anymore. He didn't want to maintain this anymore. He deleted his GitHub account. The build broke on a Friday night. Some guy came in and all he wanted to do was fix his build. He was able to reclaim that user ID in GitHub, publish the component that he already had. Luckily, he wasn't doing anything malicious, but all of a sudden, here you see, oh my gosh, right? All of a sudden, I've got this component in place that isn't, in this case, was the real component, but from a totally different publisher, right? So we're moving so fast, even on the, and that would never happen in Sonatype, of course, but the big companies are making mistakes around this kind of stuff. I mean, this is new for everybody.
In that case, how it actually happened, how he was able to reclaim that GitHub ID?
Because they allowed that at that point. GitHub allowed it. They don't allow it anymore. Yeah. It didn't exist anymore. They didn't have a check in there that says, oh, you can't reclaim because, I mean, at that point, Go is relatively new. Go just decided on a package management system. Some people say they've decided, some people haven't decided. But so March 2018, you're starting to see, okay, the Monero miners, you're starting to see this cryptocurrency starting to be infused into these packages and the packages getting compromised. You start to see a backdoor discovered in NPM. Again, so this is across all of the ecosystems in May. So this is interesting. This backdoor is discovered in NPM Get Cookies, and it was published since March. This was in May. But apparently a lot of people don't use Get Cookies, but a lot of people use the mail parser. So the people that put the hack in Get Cookies, how do you get it into mail parser? You add it as a dependency to mail parser, and then all of a sudden it's there. That's all they did, right? So now they go from, I don't know, hundreds of downloads to tens of thousands of downloads, and that vulnerability is there. So folks are getting smarter about how to infiltrate the systems. SSH decorator, the Python module, it was stealing private SSH keys, sending them to Eastern Europe unencrypted, right? So all of that data that was being stolen was unencrypted all the way to Eastern Europe. But this package, its whole job was to open SSH keys and move them around. It was a helper for SSH utilities. So any kind of security tool that you had in place that was looking for tools that were accessing SSH files and SSH keys, it's not going to pick this up because that's its whole job, right? Nobody was expecting the fact that, oh, buried underneath is we're going to just send a copy of that data over to Eastern Europe and call it good, right? And then at another point, the Linux repository is compromised. You have the ESLint. I'm going to speed through this because it kind of is scary, right? When you end up to event stream, was kind of the latest one. There's this gems backstrap SAS thing that just came out this year. I mean, we could just keep adding every week some new attack. So for us, again, this becomes even a bigger concern when you have this ability to say, okay, from the time the exploit's announced to the time it's being exploited is 3 days. What about these systems where there is no announcement, right? And there's really no good answer to this other than as quickly as the problem is found, are the systems in place for you to say, do I have this version of the component? Am I going back and looking at that? We as a company, right, are trying to find, and this is what's next for us, and I wish I had all the answers to it, But how do you secure that, right? How do you ensure that the components that we're downloading are actually the components that that I expect to have, right? Do I have to make everybody register if they contribute to my open source project? I mean, the problem is really, really hard because a lot of these happened because open source was working, right? The teams were working together. Nobody wants to see my code, right? But if I actually solve the problem and put in a pull request to something on Nexus community, it's probably going to get accepted, right? And this is the guy that puts his AWS keys in for 30 seconds. So,
Now, did you take it out of the history? I mean,
yes,
that's,
you have.
that's the other thing.
That's
You
the
don't
other thing.
understand, I mean, once you've committed it, you can take it out, but
It's there. Yeah.
anyone who's cloned that repo, you never get it
I was
back.
amazed at how fast it happened. So it's not just a story that stupid people do. Stupid pre-sale people do it too. But for us, it's when you add the crime numbers up, the money that's involved here, right? The number of CPUs that you guys put in to our build systems, to GitHub just now coming out with their actions beta, where they're firing up components that anybody can run. You can run your action inside a container every time something happens within your build cycle. I mean, think about all the stuff that can run in there that you don't know about. So that's the big fear is open source is doing its job. It's great. It's helping us accelerate software delivery, but you have to treat software delivery like a supply chain. Understanding what components are in there, being able to find the bad components, right? Just knowing that, do I have that as event stream? Most of my customers, even though they're scanning and understanding what open source components are there, they're not doing it for 100% of their applications right now. Right? So there's still these manual processes that people have to go through to actually get those components, find those components, right? So we're also trying to find ways to make sure developers can actually get the components that they need without having to go through a huge manual process of, is this component good? Can we pull this component in? We want to err on the side of, hey, if it passes the policies, give it to them, right? Because the developers and the DevOps teams, you guys, you're the only ones that know, hey, if I upgrade to this version, if I use this component, if it's going to actually work. Right? The security guy can come in all day long and say, you need to upgrade to this version. But no, I can't. Right? Well, you need to. Well, we're at a stalemate then. Which happens way more often than you think. Everybody's read the Phoenix Project, right? Whatever that guy's name is with the big binder. That's John. Thank you. The scan and skull, the scan and skull guy. So the good news is, we aren't the first industry to face the challenge. It's just really staying ahead of the use of open source components, understanding we're using those components in ways that we never imagined that we would use before, right? If I do an open source scan on my let me put this in perspective. I do this for a living. Like all the applications that I scan are bad applications, and I can rank the applications that I've scanned by risk. Right? The riskiest application is my Jenkins Docker container, right? Because it's got hundreds and hundreds of open source components that have vulnerabilities. Now, can I mitigate that risk? Can I have the developer go through and say, okay, these aren't part of it, waive them and get that risk down? Sure. But think about all of the components that you're using to build the infrastructure, to run the infrastructure, your APM tools. When I scan an application, a WAR, and then I deploy it to a Docker container, and then I tell my customer, you need to scan that Docker container again. Why? Nothing changed. Did you deploy an APM tool? Did you deploy anything else on top of it? So you really have to start to stay ahead of security. I think you were saying, somebody was saying about focusing on sec and the DevSecOps, whether it's shifting left, whatever the terminology that you want to use, just understanding these components are here, they're here to stay, and more of the applications that we typically think are COTS off the shelf, they have 80 to 90% open source components as well. Questions? How long did we go? 44 minutes? that right? I can talk more.
Yeah, you can talk more.
Yeah, so this is an interesting talk for us because it goes beyond just the, oh, here's a CVE and, you know, am I mitigating the CVE? It's really starting to understand how people are trying to make money at this and how the organized crime is actually working around some of the things that we put into place. Either pretty cool or pretty scary, whichever side you're.
There are a lot of companies who already use different sort of security scanning products like Barracuda or White Hat. And they also scan the third-party library jars, and they report they need to fix, refer back to OWASP standard, it is pointing here. How the product you are referring or spending is different from those?
Yeah, the biggest difference is that human curation of the data. So as part of the automation process, we really believe that having visibility into those open source components, even within the developer's IDE and at the build cycle and testing and release, those scans have to run and be automated. So I have to eliminate false positives. I have to make sure I'm actually focus these CVEs and vulnerability on their version. Spend a lot of time on the curation of the data. We also have a platform where I mentioned the repository manager. Part of the security piece of this is why do I let these bad things into my environment in the first place? So I have part of that human curation is saying, okay, if developers download a component through the repository manager and it has a level 10 CVE or whatever policy I failed, quarantine, right? Don't even let it into the environment. So our focus on open source from the developer all the way through to production is the differentiator, right? We don't do static code analysis. We don't, which you need, right? We run parallel with those. You need a Veracode or gosh, you think I remember the name of the company that always gets confused with that SonarQube. Yeah, you need these other tools that exist. White Hat you need, or White Hat for external vulnerabilities. So for us, it's the, we've been doing it for 10 years. We have this unique visibility, and then 50% of our engineering team is all about making sure the data is good enough to automate. Because if you're just getting file name matching, for example, like OWASP has a dependency checker. They do a scan. They do a great job of identifying all the components, but they false positive way too much because they're matching vulnerabilities to names of components. And you try to find commons, you're searching for a vulnerability with commons on all the components. That's a lot of components that are going to show up false positive. But that's the gist of it. I'm not supposed to do product stuff. I don't know. But yes.
I think what opened my eyes to the scale in the worldwide attack landscape was when I spun up a small instance on AWS and went over to guard duty and noticed the first scan from China or Bulgaria had occurred within 12 seconds.
Yeah, it really is. It really is amazing, and the reason for this automation is I shouldn't even be publishing components or applications that have known vulnerabilities. Let's go back to number 9 on that list. And the reality is that if it's known, then it shouldn't even get to production, right? So part of controlling the software development lifecycle is automating this and saying, hey, if I see these bad components in the development side and the build side, I want to warn the teams because I don't want to stifle innovation, right? I don't want to break all the builds that early, but I want to warn them. But if it gets to the release stage and production stage, and then in continuous monitoring, if I see this application with this bad component, then I need to actively do something about it, right? And you have to run these kinds of scans or notifications every 24 hours, every day.
I had no idea that access and secret keys from the AWS were being exploited so quickly. That was another eye-opener. I mean, AWS Labs has a tool called Git Secrets where you can scan your Git repositories for them, but I mean, what good does that do if you're just launching a scan, but they're able to exploit your credentials within 30 seconds?
Yep. And this is we actually, I think are we doing this with, there's one of these events we're doing with GitHub. We do a number of events with GitHub. Because what we found is, even though they have tools for doing this open source discovery and scanning on the repositories themselves, right? That's all on the source code side. That's before it ever becomes an application. So when we work together, right, they're making sure that that front end is secure. And then I can see, hey, once that thing gets checked out, GitHub doesn't have a clue what's happening over here, right? So which jars and which libraries actually get inserted in this process. Every one of your companies has developers that are taking library files from a share, a USB drive, whatever, right? They're fixing the build by putting bad components in. We know it because we see them downloaded all the time, right? So it's not necessarily, it's not necessarily that folks are trying to do something bad. They're just doing something bad because they're trying to do something good. Right?
That social problem, that's one of the hardest things to tackle because, people want to just, I see people do it all the time. Just go out and, I need a component to do a thing. Oh, I found this thing, and it's going down with it.
Yeah.
It's next to impossible to stop that.
Yeah. I'm sitting on the plane from Raleigh, Durham to Dallas. Can we turn this on again? Building plugins for our tools. And I was trying to find a way to, inside our container, when I see something checked in, I want to run a Docker command. But I actually don't want to, somebody's got to have written a library. Well, Spotify's got a good Docker client. Did I do any research on that? I mean, everything's flowing through my product. So if I got it through my repository and it passed all my policies, I can feel secure in the fact that that component's secure. But that's a perfect example. It happens so quickly, right? On the Groovy side, just trying to read a CSV file in the same little session. Well, do I get the component that's from au.so-and-so or org.apache, and it's the same freaking component. It's just got two different names. Yeah, it's hard.
Are you scanning Ansible modules? The things that run as root?
Yeah, we're scanning Docker. We'll actually break open Docker containers now and look at the application layers and find all the installed open source components and run scans against and evaluate the components that are deployed there. We partner with folks like Twistlock to do the runtime piece of it. But our philosophy is you're scanning these things before they ever get put into a container. The image might get built, but certainly don't scan it once it gets into your Kubernetes cluster, right? I mean, I've got some folks that say, well, we scan it once it gets deployed. Because you get a call back and you can do the scan. Well, it's too late. You've already deployed the thing, right? So in our world, this is where a repository manager combined with the open source scanning and research that we do, it's like we're pulling open source components from npm.js and we're filtering that and putting a firewall in place. And then once it gets built, our customers are then checking those components into the binary repository, and the only place that the other systems within the SDLC can download that application is from the repository manager. So you're starting to combine all these pieces together. Yeah, pizza good? All right, cool. Thanks, guys.
Very good information.
Yeah.
Thank you.
Thank you.
Okay, so I think just before we turn off the broadcast, I just want to make a couple of announcements, if you will. One is that we are looking for people to participate with the organization of DevOps Live, right? So if you have some capacity to help out either with maintaining a website, helping us communicate through meetup.com, want to engage in the community through Slack, or any other capacity, just come see us. Also, if you have suggestions for upcoming topics you would like to hear, that's something that we would like to hear from you. And then also, if you have recommendations for upcoming speakers, that would be great as well. That's all I got this time. So we'll be hanging out for a little bit, and I don't think that got to kick you out until like 8:30 or so. Yeah. So hang out for a bit. Yes, question.
I was just wondering, if we get the very first time,
yeah.
I was able to connect just few of us. We just tell our name, the company name, and the role they are doing in their work. It's gonna help us to connect better.
Yeah.
I'll be with myself first.
Well, so I recommend just mingling.
Okay.
So like, so, you know, we'll shut off the broadcast and then go and introduce yourself to as many people as you can. Cool? Awesome.
Good.
Cool. Thanks.
Thank you.
Bye.